Welcome to this video where we're going to be solving the system of equations that we set up in the previous video for this multi-loop circuit where we had multiple unknown currents. So if you didn't watch that video, that's actually the more important of these two, because setting up and knowing how to structure the setup and interpret a circuit and take it into a set of equations or a system of equations is the more important part for physics. At this point, if I had just given you these three equations, if you'd taken some algebra, you could solve it. Now, remember, you can solve by a variety of methods or a combination of methods, such as substitution, elimination, subtraction, or my favorite, which is the matrix. Now, the matrix is something that a lot of people aren't familiar with, which is unfortunate because it actually is very quick if you have a calculator. But because I am not able to show the calculator on the screen, I'm going to show you a different method to use because that's probably what you'd be more familiar with. If you really don't care the solving steps here and you just want to be able to check your answer for this problem, you can scroll to the end of the video and check that out. Okay, so first things first, I am going to do some substitution so that I can eliminate a variable. I have 3 here and I want to get it down to 2. So what I'm going to do here is I'm going to take this I2, which I've already solved for, and I'm going to substitute it into this equation down here. Now you could do the same thing over here. It's totally up to you. So let's go ahead and do that. We have 29 equals 7i3 plus 3i2. And now I'm going to substitute in the expression for I2, so that is I1 plus I3. Okay, we do some distribution and simplification. I have 7I3 plus 3I1 plus 3I3. I can see here combining like terms would give me 29 is equal to 10I3 plus 3I1. So that's my first step so far. Next, if you look at the equations that you have already, you can see here that we've got 3i2 and 3i2 that are similar between these two equations. So a quicker thing to do here in order to eliminate I2 and write another equation in terms of I1 and I3 would be to subtract these two equations from one another. So I'm going to do it from I'll subtract 24, this equation, 24 equals 3i1 plus 3i2 from this one. Okay, so this first step here, if you're trying to follow along, this is done by substitution and of course some simplification. And then this next step here I'm going to do by subtraction, where I'm going to subtract the two equations from one another. So I'm going to do 29 equals 7i3 plus 3i2, and I'm going to subtract the equation 24 equals 3i1 plus 3i2. Okay, so 29 minus 24 gives me 5. 7i3 minus 3i1, well, those aren't like terms, but I could do 7i3 minus 3i1 like this. And then I see that 3i2 minus 3i2 eliminates 3i2, which is what I wanted. So now I have two equations that only deal with two variables, which now I can use the next set of steps in order to solve for those variables. Now, you've got options, okay? What I might do here is I'm going to go ahead and I'll do a substitution again just to show you, even though it's a slightly longer form, that it's another, you can repeat steps, and it's sometimes the safer so you don't make mistakes, you might not see anything, but it is a much longer method. So I'm going to solve for I1 here, and then I'm going to substitute it back into this equation. Okay, so solving for I1 here, I'll divide every term by 3. So I'll have 5/3 is equal to 7/3 I3 minus I1. Okay, and now I'm going to just move some things around here, so I'm solving for I1. So I'll have I1 is equal to 7 thirds I3 minus 5 thirds, okay? And now I'm going to, for some people, these fractions really scare them, and it's actually a lot easier, especially here. You can see we have some common denominators. So when I substitute it in here, the distribution's actually not that bad, okay? So I'm going to do my substitution now, and so what I'll do is say 29 is equal to 10I3 plus 3 times this expression, which is what I1 is equal to. Okay, so when I do the distribution through here, I get 29 is equal to 10I3 plus 3 times 7 thirds, which these 3's will cancel, and I'll be left with 7I3 minus 5, because these 3's will cancel. So you see, it's not so bad. Now I can combine these like terms and the constant terms. So I'll add, let's come back up over here. So I'm going to say 29 plus 5. So I added this to this side, is equal to 17I3. So that's 34 is equal to 17I3. And then divide by 17, and I see that I3 is equal to 2 amps. So there you go. There's one of your currents. Now it's pretty easy from this step on. You know, you can substitute things in, and I'm going to go ahead and substitute I3 into I guess this equation, and we'll solve for I2. Okay, so let's go ahead and do that. So we'll say 29 is equal to 7I3 plus 3I2. I'm going to backtrack there for a second. I accidentally substituted, or almost substituted, into the wrong equation. That's 3, or into the wrong spot. Okay, so we have here 29 is equal to 14 plus 3I2. Okay, we'll subtract 14 from both sides, and that will leave us with 15, and then divide by 3, and we're left with I2 is equal to 5 amps. Okay, good. And then the last step is, this would be the easiest way to solve, and I'll go ahead and do that. Squeeze that up here in this corner. So I have I2 is 5 and I3 is 2. So I have I1 plus 2 equals 5, and so then it's easy to see that I1 has to be equal to 3 amps. So after all that work, if we come back here, we see that I1 is equal to 3 amps of current, I2 is equal to 5 amps of current, and I3 would be equal to 2 amps of current. And we can see that that makes sense according to how we drew this diagram, right? Because if I said 2 amps rolls this way, 3 amps rolls this way, when they combine at, if you think of kind of some water pooling into the same pipe here, they combine to make 5 amps. And so you can check yourself, you know, through different mechanisms, look at different ways to solve. There's also a lot of calculators online that can solve a system of equations, because ultimately setting up the equations is really the part that is more about understanding the physics. And then obviously all of this video has been to really practice some math. The matrix takes all of this work out of the situation, and if you can see matrices in systems, it's the quicker and easier way to solve with a calculator. So good luck with that, and remember to check out the opentextbc.ca website, link below, for some more practice problems.